healthy balance between the human race and the world we live in. One renewable raw material will be part of these improvements. It's the algae. The biomass of this plant is used in breakthrough development throughout various industries: cosmetics, food and dietary supplements, water recovery, and medicine. But how do you grow this microalgae? In highly efficient tubular glass systems called photobioreactors. These engineered systems deliver results that continue to astound even scientists. The reactor provides optimal growth conditions so that high-yield algae are grown with minimum contamination. A modular concept that can be flexibly adjusted to growth plans. Arranged in a compact manner, the tubes facilitate the efficient cultivation of algae within a small area.
Specializing in the commercial cultivation of microalgae, he develops, produces, and commercializes advanced algal-based products. The production process employs a closed, tubular, and environmentally protected cultivation system and recycles the cooling water involved in the manufacturing process. The advanced and controlled downstream processing of the algal biomass employs a supercritical carbon dioxide extraction.
Plant is a production environment where all the equipment is connected, so the individual units can communicate with one another. It gives customers control over their production processes all the way from incoming raw materials to palletized products. It makes their production cost-efficient, safe, and repeatable.
So that we can do very fine, precise metering of solutions. We've got very fine machined features via holes, these through holes that actually bring capillaries that are the size of a human hair onto the digital microfluidic device. And by bringing capillaries in through that space between the two pieces of glass substrate, we're able to bring the solutions on and off, bring various types of reagents on and off the device, and bring them out to different microfluidic components in a very organized and very metered and specific fashion.
With a custom-engineered Cadent Direct steam injection heater, you can rapidly, accurately, and efficiently heat liquids by injecting steam directly into the fluid. In fact, unlike conventional heat exchangers and sparge pipes, Cadent Direct steam injection water heaters provide instantaneous temperature response and large turn-down ratios to handle a wide range of flow rates, all within a compact design. By relying on advanced computer modeling, we ensure water and steam are mixed together properly, ensuring the right temperature every time for consistent, predictable results you can rely on to optimize your process. Direct steam injection requires up to 30% less steam energy to heat the fluid, totally eliminating the need for electric condensate pumps, minimizing flash steam loss, and totally eliminating cleaning or replacement of fouled or damaged tube bundles used in heat exchangers. Just think of how much money you'll save on energy costs and reduced maintenance. And it's all backed by a responsive company with on-time deliveries and DOE-certified steam system specialists. It's no wonder companies across these industries are turning to Cadent for more efficient water heating processes.
Anaerobic digestion, or AD, is a fantastic option for farmers wanting to diversify into green energy. The process, which breaks down feedstocks such as animal manures, energy crops and food waste, produces a methane-rich biogas which can then be used as electricity or heat generation. What's left is an odour-free digestate which can then be used to spread on the land as fertiliser. I'm here at Wyke Farm to speak to farmer Simon Gittins about his experiences.
Wyke Farm is a predominantly arable farm. We farm about 1,600 acres of owned and rented land. We're predominantly wheat, oilseed rape, and in the past we were potatoes and sugar beet, and also we had a dairy herd. The dairy herd was in the village of Right Levantowns. It got very difficult to be right in the middle of the village, so we got out of dairy, and then soon after that the sugar beet factory shut, so we were left in a bit of a awkward situation as to where to go from there. So at that point we started looking around, and we started looking seriously at anaerobic digestion, and that led to us building this plant last year, and we commissioned it and started running in May 2012.
Can you tell us about the AD plant and how much energy it's producing?
We started off at 500 kilowatts per hour, so that works out about 4 million kilowatts a year, and recently we've just upgraded it or increased the feeding so that we're now producing a megawatt every hour, and we're going to be taking that up to 1,300 kilowatts, 1.3 megawatts. It's proving to be a lot more efficient than the standard typical German systems.
What feedstocks do you use in the digester, and whereabouts do you source them from?
It's an agricultural digester, so we are limited to agricultural feedstocks and manures. So we put in about 30% of manures, principally broiler muck and slurry, and we also add to that maize, sugar beet, grass and triticale. But the aim for us is to maximise the amount of manures we can put in, because that's obviously, there's about 80 million tonnes of manures in the UK, and all that energy is out there being wasted, and we really want to digest it. And it also means that when it gets to the other end in the digestate, it's non-odorous, it's the fertiliser value in there's 25% more available, and it reduces our fertiliser bill by about 70%.
Well, I think anaerobic digestion offers the opportunity to deliver a range of environmental benefits. Of course, there's the on-farm energy production, electricity as well as heat, but also better nutrient management, the abatement of greenhouse gas emissions, and quite likely a route for farmers to be able to better comply with growing water resource protection measures.
Have you experienced any challenges along the way?
Yeah, because it was, we were probably one of the first, well, definitely in this area, there was a lot of concerns locally, proven to be unfounded, but it's quite a stressful time doing planning, as you can imagine, and trying to get over the truth can be difficult, but I think we managed that, and we were, we started running last May, and I think, hopefully, I'd like to think that the neighbours think that it's no problem.
The industry has been relatively slow to take off. This is a more complex technology than just putting up a wind turbine or putting some solar photovoltaics on your farm buildings. You do need operator skills, the engineering is more complex. I think there is a great opportunity in the UK to follow the route of other European member states like Germany and build an industry, both in terms of farmers being able to use the technology and also the manufacturing supply chain to support it.
And how has the AD plant transformed your business?
It's fantastic. I mean, as I say, we were in a position where we were the potatoes are gone, the dairy gone, sugar beet gone. We were down to just arable acreage, cereals, and at that time, 5 years ago, cereals were what, £90 a tonne. So we were really concerned about where the farm went. So we wanted to diversify. At that time, the politicians were saying, farmers, we want you to not only grow food, we want you to look after the environment, and we also want you to produce renewable energy. So we thought, well, let's go for all three. So we've got quite an extensive HLS agreement, high level stewardship scheme. So we have 100 acres just behind us over there we flooded for wading birds. We have a lot of wild bird mix and all sorts of other measures. We plant probably 1,000 trees and shrubs each year. And then on top of that, we obviously grow the crops for food. And additionally now, we produce renewable energy. And it's a real good mix. They all work together very, very well. For example, growing energy crops, spring cropping means that you get more overwintered stubbles, which is better for bird life and more varied for the area. And also producing all the organic fertilizer means that we can put that back on the soil, which saves on very energy intensively made bagma.
There is a role in the agricultural sector as well as just in sort of large waste management companies dealing with food processing wastes and post-consumer green waste and so on. A lot of agricultural feedstock that currently has little value can be used in these plants to deliver, as I said, these energy and environment benefits on farm.
And that produces biogas. Biogas is about 55% methane. And that runs these two engines here, which are effectively big marine diesel engines with petrol tops and a big turbo. So the gas replaces the petrol. That runs a big alternator which produces the electricity. We produce about, as I say, about 1,000 kilowatts each hour, which is enough for about 1,200 or 1,400 homes. And we use about 7 to 10% on site to run the farm and potato stores and other things, and the rest goes into the national grid and is used locally.
Cryoper has developed a unique solution for the production of biofuel and bio-CO2 using organic waste. A source of renewable energy, Cryoper transforms the biogas recovered from our waste through cryocondensation to obtain bio-CO2 and biomethane, both of which are liquid and more than 99% pure. Once transformed into its liquid form, the biomethane, or bio-LNG, divides its volume by 600 compared to its gaseous form. It can therefore be used to provide trucks and boats with renewable fuel. It is the only clean alternative to diesel for long-distance haulage. Another decisive advantage with the liquid form is that the biomethane is easy to store and to transport. Bio-LNG compensates the lack of natural gas grids. The Cryoper solution, therefore, solves the problem of biomethane transport and makes possible a large number of projects which cannot be connected to the grid. Out of the 8 billion tons of organic waste resources produced each year on the planet, Cryoper focuses on the 4 largest sources: industrial waste, organic household waste, sewage sludge, and agricultural waste. And here are a few examples. A first Cryoper installation was set up in France at a water treatment plant in the Paris area in partnership with Suez. It enables the transformation of the biogas from the sewage sludge into liquid biofuel with no greenhouse gas emissions and considerably reduced air pollution. This bio-LNG is used by local authorities and industries for the transport of persons and goods. Another Cryoper plant in the UK allows the Greenville Energy Farm to boost its revenues from its biogas by becoming a local energy supplier with its own production of bio-LNG. As a pioneer for sustainable development in a world in which the public authorities push for reducing greenhouse gas emissions, Cryoper enables industrial companies and farmers to sell their own production of renewable energy. Cryoper creates value for its customers through the use of biogas, thanks to a patented process which is unique in the world, and is currently planning projects in Italy, Sweden, France, the UK, and the Netherlands, but also later in Indonesia, in the USA, in Brazil, and in New Zealand. Cryoper concentrates a diluted energy and creates new revenues from biosources.
Alar's AutoVac system effectively removes solid particles from the sludge, producing dewatered dry waste. The Alar AutoVac filtering system is skid-mounted, pre-piped, and pre-wired for easy installation.
This design works with virtually any industrial waste, such as coolants, cleaners, and process water.
The operator charges the pre-coat tank with filtering media called diatomaceous earth, or DE. The DE slurry overflows into the filter pan, and the vacuum draws the DE filter media onto the cloth. This pre-coat operation takes about 15 minutes and is performed with each shift, building up a 3-inch cake. The water passes through the DE media and out a hollow shaft. This DE media is capable of removing particles as minute as 1/2 of a micron. That's 1/2 of 1/1000th of a millimeter. Filtering is performed in much the same manner as pre-coating. The wastewater is pumped into the pan. The level controllers located within the pan maintain a constant liquid level, eliminating the need for operator attention. The vacuum draws the liquid through the DE media and out the shaft. The solids are trapped on the surface of the diatomaceous earth, where they are air-dried for 2/3 of a revolution of the filter drum. This process removes virtually all of the free moisture by drawing an amazing vacuum of 26 inches of mercury. These solids are continuously removed from the surface of the cake by an extremely durable stellite knife blade, advancing with lathe-like precision, leaving a clean surface as the drum re-enters the sludge. The AutoVac is self-cleaning with every revolution, which prevents blinding or clogging and provides rapid filtration and extremely high filtrate clarity. From start to finish, the AutoVac is designed for ease of operation with minimal manpower required, providing remarkable results. The Alar AutoVac substantially reduces operation and disposal costs by typically achieving reduction in volume of 90 to 95%.
Anaerobic digestion is a controlled biological process using biodegradable materials such as food waste and animal manures to produce renewable energy. That's biogas, electricity and heat, and valuable digestate that can be used by farmers. There are over 100 anaerobic digesters operational in the UK, with many more in planning or being built.
Today we're at our Wallingford AD plant. Behind me you can see some of the digestion tanks and our gas engines. So food waste comes in through the reception building where it's processed and prepared, and then enters the digestion tanks where bacteria start to break down the food waste in the absence of oxygen, giving off methane and other mixtures of gases which we capture in the domed roofs. We clean it up and then we feed it through the gas engines, also behind me, which burn the gas in a standard internal combustion engine, converting it into electricity, which we feed into the national grid. And this plant produces enough electricity to feed around 4,000 houses. As well as the electricity, we are left with a whole liquid fertiliser called Digestate, which we spread back to farmland as a nutritious product to grow crops.
Any AD unit treating animal byproducts, such as cooked and uncooked meat or catering waste, must use a pasteurisation step in the AD process to ensure that the digestate is safe to use. Testing has shown that after pasteurisation, pathogen levels in digestate are a fraction of the levels in other organic materials used in farming, such as manures and slurries. Planning. Typically, the whole digestate has 5 kilograms per tonne of total nitrogen, of which 80% or 4 kilograms per tonne is present as readily available nitrogen. This is more potent than cattle slurry, which has only 45% readily available N. Old Digestate also typically contains 0.5 kilos per tonne of phosphate, which is 50% available, and 2 kilos of potash, which is 80% available.
The beauty of the Digestate is it's a complete nutrient feed for the crop in one materials. You can't actually source this type of product in manufactured means. It's because it comes from the AD plant here, which is based on food waste. It's got a complete mix of nutrient which the plants pick up very readily.